In this video, we're going to look at how to evaluate inverse trig functions. Before we start, it's helpful to have the domain and the range of your sine, cosine, and tangent functions and their inverse functions written down so that you can refer back to that. So that's what I've done here in this chart. So my inverses are arcsine, arccosine, and arctan. Because when we evaluate, our answers have to fall within these domain and ranges, so it's nice to have those there. And you will need to memorize those, but for right now, we have them written down. Okay, so we're going to start with a very simple example. I just want to find the arcsine of -1/2. Okay, now hopefully you have your unit circle memorized by now, but if not, let me put it out here just for reference. Okay. And now let me zoom out just a little bit. Okay, when you see the word arc or the little -1 on sine, remember what that means is, the inverse. So you're trying to find the angle that has -1/2 as its sine value. So another way to think of this is what angle has a sine of -1/2. Okay, remember in the unit circle that the sine is the y value, so you're looking for angles that have a y value of -1/2. Well, there's going to be two answers for most of these. If you look here at 11/6, it has a y value of -1/2, but if you look over here at 7/6, it also has a y value of -1/2. So I'm going to jot those angles down. So far we have 7/6 and 11/6. All right, the problem with both of those angles is they don't fit in the domain and the range that we need. So keep this in mind. This right here is your input. What you're finding as the answer is your output, okay? Output is considered range. So I have to make sure that my answer fits the range of arcsine. So arcsine's range is -π/2 to π/2. Neither one of these fit in that range. They're both too large. So what you want to do now is you want to find coterminal angles for these two angles. Remember, coterminal means you just add or subtract 2π. Since these are too big, I'm going to subtract 2π. So if I take 7/6, remember, don't put the pi in there, subtract 2 for 2π, and then change that to a fraction, you get -5/6. So this angle is the equivalent of -5π/6. Let's do the same thing for 11/6. So take 11/6, subtract a revolution, change it to a fraction. I get -1/6, so that's just -π/6. Once you've done that, only one of these answers should fit into the range that you're looking for. So if we're looking at -π/2 to +π/2, that's like -1/2 to +1/2. Which of those would fit in that range? Well, -5/6 is smaller than -1/2, so it doesn't fit. -1/6, though, does fit in there. So our answer to this one is -π/6. So you have to have knowledge of the unit circle. You also have to have knowledge of domain and range to be able to do these problems. All right, let's try another one. Let's do the arccosine of -1. Okay, so this just means what angle in the unit circle has a cosine of -1. Remember, cosine is the x value. There's only one place. Right here, our x value is -1. So our answer can only be pi. Now what we need to do is we need to make sure that pi fits in arccosine's range. Arccosine's range is 0 to pi, so pi fits. So that's our answer. Okay, let's try the cosine inverse of √2/2. Now remember, cosine inverse is the same as arccosine. I'm just writing these in different ways so that you get used to seeing it. All right, so we want to find an angle in the unit circle that has √2/2 as its x value, since we're doing cosine. Well, there's two of them. Here's your first one, pi fourths. And Here is your second one, 7 pi fourths. All right, let's see if either one of those fits in arc cosine's range, which is 0 to pi. Pi fourths already falls between 0 to pi. 7 pi fourths is too big, so pi fourths is our answer. So sometimes you don't have to do the thing where you add 2 pi and subtract 2 pi, finding the coterminal angle. Sometimes you don't have to do that because your angles already fit. If they don't fit, that's when you need to do that. All right, let's try another one. Let's find the tangent inverse of 0. Okay, so this means where in the unit circle is the tangent 0? Now you got to remember what tangent is to be able to do this. Tangent is y over x, or sine over cosine. Well, 0 divided by anything is going to be 0, so we need to make sure our y value is 0. That way when we do y divided by x, we get 0. So where is our y value 0? That would be here at 0 radians, and it would also be here at pi radians. So 0 and pi. Which of those fits into arctan's range? So from negative pi halves to pi halves, 0 would fit in there. Pi would be too large. All right, let's do a couple more. Okay, let's do the sine inverse of square root 3 over 2. Sine inverse of square root 3 over 2. So where in the unit circle is the sine, or the y value, square root 3 over 2? All right, that occurs right here at pi thirds. It also occurs right here at 2 pi thirds. Okay, now we need to look at arcsine's range, which is negative pi halves to pi halves. Pi thirds already fits there. So 2 pi thirds is out, it's too large. Pi thirds is our answer. Now if you'll notice on the 5 examples that we've done, all of the values that were in parentheses, it was pretty easy to notice that those were straight from the unit circle. When you see values that look like unit circle values, like 0 and 1, square root 2 over 2, square root 3 over 2, and 1/2. When you see those values, those are coming straight from the unit circle, and you should be able to do those problems without a calculator. All right, occasionally though, you'll get a problem that looks like this. Arcsine of 0.45. Okay, 0.45 is not something that we have in the unit circle. So you are allowed to use calculators on decimal values like that. So to do it, you need to pay attention to what instructions you're given if you want your answer to be in radians or degrees. If your instructions say give me an answer, from 0 to 2 pi, or from negative pi halves to pi halves, or what have you, then you know you're dealing with radians. If it says to give an answer from 0 to 180, then you're talking about degrees. So pay attention to your instructions. We've been doing everything in radians so far, so I'm going to stick with radians. So hit mode, make sure you're in radian mode, and I'm not, so I'm going to switch to radian mode. If you're using Desmos, you switch your mode by going up to the right-hand corner of your screen and clicking on the wrench, and then you can switch between radians and degrees. Okay, so now arcsine, remember, that is inverse sine, so I'm going to hit second sine. It puts the little -1 there for me. I'm going to put in 0.45, and there's my answer. And you'll be told what to round to. For right now, I'm just going to do the nearest hundredth, so that would be 0.47 radians as my answer. Okay, so those are pretty easy evaluations. Now we want to look at some harder ones. I'm going to get another sheet of paper so that I don't have to keep flipping this one over to look at the domain and the range. Actually, let me just fold this up. We're going to keep that handy, the domain and range handy. Okay, let's see how I can do this here. All right, so now we're going to do some compositions where you're evaluating more than one thing. Okay, I don't know what number I was on. Let's see. We were on 6. Let's look at 7. Okay, for number 7, What if I was asked to find the sine of the cosine inverse of square root 2 over 2? Okay, so on these problems, you have to work from the inside out. You have to do the inside part first, make sure you get the right answer there, and then do the outer function, okay? So the first thing I'm going to do is find where the cosine is square root 2 over 2. Okay, now I don't have the unit circle in front of me anymore, so you're going to have to kind of do this from memory. The cosine is square root 2 over 2 at the angle pi fourths and at the angle 7 pi fourths. All right, out of those two angles, which one fits the arc cosine's range, which is 0 to pi? Pi fourths fits. Okay, so that's the one I'm going to use for my outer function. So now I want to find, okay, what is the sine of pi fourths? Now I'm not looking for an angle answer. I have the angle. Now I'm looking for a ratio answer. Ratio means you're looking for the 1/2 or the square root 3 over 2 or the 0 or the 1 or the square root 2 over 2, okay? So now I want to go to pi halves in the unit circle and find my y value because sine is y. At pi fourths, my y value is square root 2 over 2. That's my answer. Okay, so just remember you're working from the inside out. Let's try another one. All right, let's try the sine inverse of the sine of 5 pi thirds. Okay, so the first thing I'm going to do, and I should have had an extra set of parentheses there. The first thing I'm going to do is figure out, okay, what is the sine of 5 pi thirds? Now, this is not arc sine. This is just sine of 5 pi thirds. So I'm looking for the 1/2 or the square root 3 over 2 or the square root 2 over 2. So in your unit circle, if you go to 5 pi thirds, you're down in quadrant 4. Sine is the y value. The y value there is negative square root 3 over 2. Okay, now I want to find the sine inverse of negative square root 3 over 2. So where is the sine negative square root 3 over 2 at? Well, obviously it's at the angle that we just dealt with, 5 pi thirds, but it's also at another one. The sine is also negative in quadrant 3. So if you're looking at your unit circle and you're in quadrant 3 down at 4 pi thirds, you also have a sine of negative square root 3 over 2. So these are your two angles that work. But only one of those angles is going to fit into sine inverse's range. Remember that arc sine's range is negative pi halves to pi halves. So neither one of these immediately fit. So we're going to have to do the thing where we subtract 2 pi and see which one fits then. Okay, so if you're going to use your calculator, you would have 4 thirds. You're going to subtract 2 pi. You get negative 2 thirds. So negative 2 pi thirds is that angle. And then if you have 5 thirds and you subtract 2 pi, you get negative 1 third. So negative pi thirds. All right, now that we have those angles smaller, which one of those fits arc sine's range? Which one falls between negative pi halves to pi halves? And it would be negative pi thirds. So that's your answer. Here's another neat thing about that one. Anytime you're doing a composition that has the same trig function in it, sine and arc sine, or it could be cosine and arc cosine, or tan and cotan, when that happens, lots of times this angle right here is your answer. It just may not be in the right form yet. Remember that a function and its inverse undo each other. So technically this and this cancel each other out. And this is my answer. It was just in the wrong form. See, notice that's the one that became my correct answer. It was just in the wrong form. It needed to be smaller. So that'll happen on those problems. Let's do a couple more of these. All right, number 9. Let's do the cosine of the arctan of negative square root 3. The cosine of the arctan of negative square root 3. All right, so we're going to start here. with where is the tangent negative square root 3 at? Okay, now this one takes a little bit of work. Tangent, remember, is sine over cosine, or y over x. So if you think about your ordered pairs in the unit circle, every time you see an ordered pair that looks like this, if I do y divided by x, square root 3 over 2 divided by 1/2, remember my 2's are going to cancel, I get square root 3 as my answer. Okay, so I'm trying to think of places in the unit circle that have this as their ordered pair. Okay, but one of them's got to be negative in order to have a negative here. So we're thinking about quadrants 2 and 4 would have one of these negative. Okay, so in quadrant 2, I have a negative 1/2 and a square root 3 over 2, and that happens at 2 pi thirds. In quadrant 4, I have a positive 1/2 and a negative square root 3 over 2, and that happens at 5 pi thirds. So those are the two angles that we're dealing with. Okay, which of those falls in arctan's range? Neither one of them, they're both too large, so we're going to subtract 2 pi. If you subtract 2 pi from 2 pi thirds, you get negative 4 pi thirds. If you subtract 2 pi from 5 pi thirds, you get negative 1/3, so negative pi thirds. This is the one that falls in that range. Okay, so what we want to do now is find the cosine of negative pi thirds. Okay, so now we're looking for a ratio answer, not an angle answer. We already have an angle as our input, so the ratio is our output. So the way you want to do this is you want to go to the unit circle to negative pi thirds. Now that means instead of going counterclockwise around the unit circle, you go clockwise, negative pi thirds, or what you can do is you can treat that as its positive angle. If you're more familiar with positive angles in the unit circle, which most of us probably are, remember that negative pi thirds is just 5 pi thirds written another way. So if you want to think of it as what is the cosine of 5 pi thirds? All right, the cosine of 5 pi thirds in the unit circle is 1/2. So 1/2 is your answer. Let's do a couple more compositions. All right, let's do the arcsine of the cosine of negative pi thirds. Okay, so we're going to start here. We want to find the cosine of negative pi thirds, and we just did that in the last problem. The cosine of negative pi thirds is really the cosine of 5 pi thirds, which was 1/2. So we already know that that's 1/2. Okay, so what we want to do is find the arcsine of 1/2. In other words, where in the unit circle is the sign 1/2 at? Well, the sign is going to be 1/2 at, remember sine is your y value, that happens at pi sixth. That also happens at 5 pi sixth. All right, which of those fit into arcsine's range? Negative pi halves to pi halves. Pi sixths fits, so that's your answer. All right, what about something like this? The tan of the tan inverse of negative 5. Okay, the first thing I notice about that is negative 5 is not a unit circle value. So this is a problem that I could easily use my calculator on. The other thing I notice about it is these are the same trig functions except one's the inverse, which means technically they should cancel each other out and I should get negative 5 as my answer. So since this would be a calculator problem, let's just do it and see if that's what we get. Tan of tan inverse of negative 5, and negative 5 is our answer. All right, let's do one last composition. Let's do the cosine of the cosine inverse of pi. All right, so we're going to start here. All right, remember this means where is the cosine pi at? Now this one could be tricky because pi is something from the unit circle. But remember, this is your input. This is your ratio, and you're trying to give the angle as an answer. So what this really means is, where in the unit circle is pi my x value? Okay, and if you're looking at the unit circle, we have an angle called pi, but that's not what we're wanting. We're wanting an x value that's pi. If you go around your unit circle, you don't have any x values that are pi. Okay, so this should be undefined as our answer. I would double check it in the calculator. Let's do the cosine of the cosine inverse of pi. And you get an error, okay, because remember that cosine has a maximum value of 1 and a minimum value of -1. As you go around the unit circle, none of your x values exceed 1 or are below -1 as you go around. But pi is 3.14. So there can be no angle in the unit circle that has 3.14 as its cosine value, because it exceeds the 1 limit. So that would be undefined. So don't be afraid to check your answers in the calculator, but I want you to be able to do the ones that look like very clear unit circle values without having to use a calculator. When you take your next test, which is very soon, on the trig graphs and the inverse trig functions, I'm going to expect you to give exact values as your answer when it's a unit circle type problem. For example, right here, I would want -pi3 as the answer, not a decimal value. Okay, so make sure that you've really got that unit circle down pat. Make sure you also have the range, especially, of your arc sine, arc cosine, and arc tangent graphs memorized, so that when you give your answers, you know that your answers are falling in the right range values.